All right, thank you. This video is for parents and students for doing the area model and partial products for multiplication up to 4x1 and 2x2. So I'm just going to kind of take you through the philosophy of it. I often ask parents when they ask me, why are you doing it this way? I say, okay, can your kids do 5 things in a row? No. So we're learning that kids learn differently today and they need to know the why behind the how. So we picked 2 models that we're going to teach in 4th grade. 5th grade will eventually do what you know as the algorithm or the standard way of doing multiplication. So today I'm just going to start with some simple problems. And I'm going to have my students help me out a little bit because they like to be the number generators. So I need a 4-digit number. Somebody help me out. Florida.
4-digit number. 1,931.
31. Fantastic number. Somebody give me a 1-digit number. Jackson.
9.
9. You love those 9s, boy. All right. All right, so the traditional algorithm tells us to do this, carry, and do all that other stuff. We're trying to simplify it so that the kids will understand the mathematics and then eventually develop into the algorithm. So what we're going to do is we're going to first do what we call the area model. And the area model represents a rectangle. And you'll have to forgive my non-straight drawing. But it's supposed to represent a rectangle that has both length and width. So it is going to be 9 tall. It's going to be 1,900. And that scale is going to be all messed up. I'm going to extend out a little bit to help us out. And 30 and 1. So what we're doing is we're decomposing the top number into place value. And we're drawing a rectangle that's going to help us to use as a model. So what I do is I take the numbers and I go 9 times 1. It's just like a multiplication chart. 9 times 30 is 27, and then times 10. And 9 times 900 is 9 times 9, which is 81, times 10, times 10. And I usually have the kids repeat the times 10 to make sure that they understand that the zeros mean times 10. 9 times 1,000 is 9 times 10 times 10 times 10. So you see you have all these different numbers in here, and then what you have to do is you have to line them up and add. The pitfall here is that a lot of times kids have trouble lining them up by digits. So keep a close eye on that, the digits are all lined up. Then we just use traditional addition algorithm to add up. And I think I'm right. All right. That's one example of how to do a multiplication problem, and it's a little bit more visual. Another way we do it is similar, but this is the bridge between this and doing the standard way that you moms and dads and grandmas and grandpas and folks that take care of these babies are used to doing it. So what we do is we take 1s times 1s, and 1 times 1 is always 1. So we're talking place value when we do this. So kind of stick with me and I'll show you what I'm talking about. We've got 10 times 1 equals 10. We've got 100 times 1 equals 100. We've got 1,000 times 1 equals 1,000. And the reason I'm writing those facts over there is because we're going to talk place value as we go through these partials. So right here I have 1 times 9 1s. 1s times 1s is always 1s, so it's 9 1s. So that one there is 1 times 9. Next we're going to go to the tens place, and we have 10s times 1s, so it's going to be 10s. Because it's times 10, I can write a 0 there because I'm moving one place value to the left. So 3 times 9 is 27 tens. So I write the 27, 2 in the hundreds, 7 in the tens place. So that one was 30 times 9. Next we have hundreds times 1. So I know I can put 2 zeros there because I'm in the hundreds place now. So 9 times 9 is 81 hundredths. So I've got 900 times 9. Now I'm going to the thousands, and 1,000s times a 1 is thousands, and that has 3 zeros. So I have 1,000 times 9, and it's 9,000. I'm going to add those up, and I'm going to come up with 9, 7 in the tens, 3 in the hundreds, and 17 in the thousands, or 7 in the thousands and 1 in the 10,000s. Now I know what you're thinking, because the kids always complain about it too. That's a lot of writing to do. Well, it is, but if the understanding's there, when the kid gets messed up, when they get to 3x2s and 4x3s later, they're going to have a system to fall back on in order to figure it out rather than trying to go step by step. Because like I told you before, trying to tell a kid what to do 5 steps out is very difficult for them to follow. The next thing I want to say is I know that parents always say, well, I've always done it this way. I told my kids a joke this morning. I said, well, if we always did things the way we've always done it, we'd all still be riding horses. So I hope you'll stay with us and follow along. Our goal in 4th grade is to get the children to what we call a 2x2 multiplication. All right? And that just means 2 digits by 2 digits. So I'm going to use my little monkeys as number generators again. And their hands are already going up and they're grunting to give me the number. I love it. I need a 2-digit number, babies. Mia.
92.
92. Fantastic number. Need another 2-digit number? Destiny? Can we pick a 2-digit number that maybe doesn't have a 0 in it just for complication? We want to make it a little more complicated?
22.
22. Love it. Kind of a cheating number, but I know what you're doing. Love it. All right. In this model, we're going to draw a 2x2 bar, and what we find out is drawing it to scale at first helps, but eventually it's just going to be a tool to use as a model. But I'm going to try and draw it as best I can to scale to prove that there is an area to it that's actually a rectangle. So we've got We've got 22, and we broke it into 2 pieces, and we've got 92, and so now we've got our area model. All right, we can do this in any order using the area model, but I like to start with the ones to the ones right now just to show how we're eventually going to get to the algorithm. So I'm going to go 2 ones times 2 ones, and it works just like a multiplication chart where they come down together, and that's going to be a little 4 in there. Okay? Then I'm going to take the 90 times 2, and I've got 2 times 9, which is 18 times 10. Then I've got 20 times 2, which goes into this box here, which is 2 times 2, which is 4 times 10. I've got 20 times 90, which is 2 times 9, which is 18 times 10 times 10. Take all of my partials. Make sure that they're lined up. Add them up, and I have a 4 in the ones. I have 12 in the tens, so I'm going to put 2 in the ones. Regroup 10 tens into the hundreds. Regroup again. 2024. When I go to do partials, I'm going to come over here and I'm going to do ones times ones, and remember 1 times 1 is always going to give me a 1, so I put the 4 in the ones place. So that's 2 times 2 equals 4. Tens times ones is going to give me tens, so I know I can put a 0 here. 9 times 2 is 18 tens. 90 times 2. Now I'm going to go ones times tens again, which is going to give me 10, so I can put a 0 there. And so this time I have 2 times 20, which is 40. Next I'm going to go tens times tens, which gives me hundreds. So I can put 2 zeros there. And I have 90 times 20, which is 9 times 2 is 18. And here's those 2 zeros that match the tens times tens. So it's 1800s. Line them up, add them. And this is the part where you always pray as a teacher that you get it right, because these little nuggets like to point out when you're wrong. All right. Good job, that's perfect. Oh, that's right. You're here because we're supposed to be phone. Yes, sir.
Nicholas, can you tell me what you're doing?
I'm doing an area model.
Area model. And can you tell me what the problem is?
4421 times 8.
Good. And what is that? That first number there.
4,000.
And what place is it?
Thousands place.
Okay, Nicholas, can you explain what you just did there? Talk a little bit about it.
With the X's.
Yep.
So each 0 up there, I put down there, then X it out.
Okay. So you took each number times the 8, correct? Yeah, you want to move that over maybe to the other side? Yeah, there you go. There you go. There you go. There you go. Now what are you doing?
Adding it together.
Adding. What did you get?
35,368.
Good job. Good job. Everyone, I have you.
Tens place.
Tens place, so multiplying by
10.
10. All right.
Awesome.
You're as sloppy as me. All right. So.
Good job, Lefty. Okay, Maddie, what are you doing?
Photo project.
Okay, awesome. Show us. What did you just do there?
I did 8 times 1 and it goes here.
Okay.
And now 8.
Why did you write a 0 there, man?
Yeah, why did you write it there?
Because this is in the 10 spot.
Perfect.
Why did you put 2 zeros there?
Because it's in the hundreds. Done.
Awesome. Well, what did you get?
35,368.
Do the answers match?
Good job.
Yes.
So who's correct?
Both.
Thank you.
Good job, Maddie.
See? That's not bad. There you go. Awesome. Alex is still taping you.
Oh, close your eyes. Boom. I know this is against the schools and a healthy snack policy. You better look, Miss Fowler. You'll have to get the ear with it. Boom. Raise your hand if you didn't get one yet. Boom. Good. Rex. Did you get one? Hey, camera people. Pay attention. Don't laugh. Pay attention. Miss Fowler. There you go. Maddie, did you get one? All right, please remember the proper way to swap them. If you want to swap, you hold it up. You find somebody that's holding one up that you want.
That's so fancy.